Hey everyone, it's Mr. Canfield. This is Geometry, Chapter 9.2, or I'm calling it 9.2, doing circles. So we are gonna breeze through this. It moves pretty fast. So I'm actually gonna skip the beginning. If you have access to this handout, I do recommend thinking through the beginning of this. But the one thing I'll talk about is a circle. So if something's a circle, it's perfectly round in all directions. That would be kind of a basic way to talk about it, but officially, a circle is defined by a center point, and then every point that is the same distance from that center, that's what the circle is. The circle is not the center, it's all these points. And that distance is called a radius. So that is what a circle is. So there was a typo on this problem. If you have a newer digital version or a newer version, it probably is fixed. Okay, so this is what we call the equation of a circle in standard form. And it might look really complicated, but there's only really 3 pieces of information we need, and it's right here. Boom, boom, boom. And if you look around on the rest of the page, they're all in this format. If I see an equation in this format, this is the equation of a circle. And it says the center is 2, -3. And so what you might notice is it says x minus 2, y plus 3. It's telling me x is the opposite of what I see here, is regular 2. Y is the opposite of what I see here, -3. And then we'll come back to that in a minute. So the center is 2, -3. So that's 1, 2, 1, 2, 3. I'm getting a little bit ahead of myself graphing that, but the thing to notice is that these numbers are always the opposite of those numbers. And I would write something down about that, like, you know, some kind of visual notes for yourself to understand. The radius is 5. So how does that work? Well, look at this number here. How is 5 related to this? And it's like this: the square root of 25 is equal to 5. So square root of that number is your radius every time. So here's how we graph it. Here's my center. I already graphed that. Now the radius is 5, so I go 1, 2, 3, 4, 5. You go in each direction. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now, what you don't do is you don't go 1, 2, 3, 4, 5. You don't go there. That's not 5, because a diagonal space there, if you think about that, that's a little tiny right triangle, and that diagonal is not the same length as the 2 legs. If we did a squared plus b squared equals c squared, we'd see that is actually 1.4-ish. So 1.4, 2.8, 4.2, like 5 is somewhere in here. So it's not an easy thing to count. And if you're like, what the heck did you just do? Don't worry about it. But these 4 dots, and then you do your best to draw a circle out of it. So that's not too bad. So I'll do a couple more examples, and I'll draw worse versions, and I will show you the one way you can lose points trying to draw a circle in a minute. So, all right, 5. Find the center and radius for each circle. Okay, and then graph it. So the center here, well, it says -1 and -3 for my x and y, so that means that it'd be 1, 3. And then square root of 16 is 4, so that's my radius. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 4. Okay, so here's how you lose points. If you draw straight lines connecting those, I don't believe you understand that we're trying to draw a circle. There's a big difference between this and what I'm about to do. This is how you lose points on a circle question, though. So let's do the next one. Let's see, I see a +2 and a +5. That means a -2 and a -5. 1, 2, 1, 2, 3, 4, 5. All right. So All right, let's see. I see a 4 there. So square root of 4 is 2. So 1, 2, 1, 2, 1, 2, 1, 2. All right. So big difference from this to this. You might think that this looks a lot like that, but I can tell that the person drawing this was trying to draw a circle and just wasn't a very good artist. Like, that's totally fine. All right. Let's see, center. So I see a +4, so that's a -4. I see a -8, so that's a +8. And oh, wait, what's the square root of 1? A lot of people ask me this, and I'm like, why are you asking me? You have a calculator. Yeah, but I can't type square root of 1. All right, so -4, 8. 1, 2, 3, 4, 5, 6, 7, 8. And we'll go 1 in each direction. Little baby circle. Whee! All right. Something important when you're doing these, make sure that your dots, the points that you draw for the circle, are noticeable. If you can't tell that they're there, it's kind of unhelpful to anybody trying to figure out what you're doing. All right, let's look at our next one. 7, -2. My radius is 3. Follow the same procedure as earlier if you're not sure how I got that. 1, 2, 3, 4, 5, 6, 7. 1, 2, and then 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2. Whoop. 1, 2, 3. Okay. That's how I would do it. I would have 2 colors. It's more fun. If you're like, what are you talking about how you would do it? You just did a bunch of examples. Yeah, okay. That's a fair point. All right, on to the back. You can kind of see the front through. I'll just grab another paper. Just do this again. All right. So these, we're doing the reverse. But before we do that, let's just talk about this. This is how you're going to see the formula in the future. And it gives us little hints. It says x minus h, y minus k. They've got the squares on it. They got the r squared. So skip ahead a minute or so until I start doing these if you're not interested in there's some cool stuff going on here. Excuse me. First thing that's interesting is something squared plus something squared equals something squared. That might bring you back to this. That's for triangles. How is a thing that shows a circle coming from triangles? If you're really thinking about that, that should bother you a little bit. You'll see more about this if you take pre-calc. When you study trigonometry there, you'll see how these are actually related. It's a pretty neat thing. We call it the unit circle, but that's for another course. So that's something kind of interesting. Here's the next thing that's kind of interesting. It says x minus h, y minus k. That's to remind us. This formula reminds us it's always the opposite of what we see. Those minuses do the opposite. So that's helpful. And then over here you see r squared. Whatever radius is, it gets squared. So if I'm trying to build an equation from a picture, it really is just what we did before. So I look at my center. I see my center is -3, 1. So that means that here, well, if it was -3, that means we would need to see a +3 here to make it work, right? Because it needs to be the opposite. And instead of seeing a 1 here, I need to see a -1. And then my radius, 1, 2, 3. My radius is 3. And if you remember earlier on the front when we were doing this, oh yeah, I don't have anything written on the front of this paper, I'm using the second paper. We took the square root to find the radius. So if I know the radius, how do I unsquare root it? You square it. 4 squared is 16. So here, 3 squared is 9, so 9 goes there. And that would be the equation of this first circle. And that's all these. That's all. Like, there's no secrets. We're only going to see one little wrinkle But besides that, everything is really straightforward. So I see my center here is 3, 1. So that's x minus 3 and y minus 1. And then my radius is just 1. 1 squared is 1. This is not a correct answer, what I wrote here, though. And the problem is I'm missing stuff. It needs to have this thing squared and this thing squared, and it needs to have the plus sign in between. Otherwise, we're describing something else. So the symbols that we write actually matter. So we'll leave the wrinkle for a minute. Here my center is -1, 3. So that's x plus 1 then, and y minus 3. And my radius is 2. So 2 squared is 4. And then let's see, last one, my radius is 1, 2, 3, 4, 5, 6. So 6 squared is 36. I know I'm kind of doing this in backwards order. It doesn't matter. All right, so my center is 1, -1. So the 1 turns into a -1, the -1 turns into a +1. All right, and last one. Okay, so this one, my center is 0, 0. My radius is 6, so it'll equal 36. There's 2 ways you can do this. You can literally say x minus 0 squared plus y minus 0 squared. This is completely correct. But what is x minus 0? If you think about this, like x can be any number, kind of. Like that's how you're kind of thinking about what x is. Okay, so if x is a number, what happens when I subtract 0 from it? Pick a number, subtract 0. What did you get? The same number. So a lot of times, instead of writing this, we'll write this. X squared plus y squared equals 36. This is the common way that you'll see this. And on your homework, you'll see that. Well, I hope this video was helpful. Definitely would try and make it brief. So, yeah, bye.